So good evening, students. We'll just wait for another 2 minutes to let other people join, and then we may start the session for today. Okay, fine. Let's start our session as of now. So good evening, everyone. Uh, am I audible to you guys? Yes, right, audible, I guess. So I welcome you all for the problem solving session 2 of the course Biointerface Engineering. So today we'll solve the assignment for week 2, which is not typically the assignment, but we'll solve certain questions which will help you further solve the problem of the assignment 2. So this course, Biointerface Engineering, uh, is being taught by Dr. Lalit Mohan Pandey. He is the Associate Professor in the Department of Biosciences and Bioengineering, IIT Guwahati. And I myself am Shilpa Nandi. I am a research scholar in the Center for Environment, IIT Guwahati. So this is basically a doubts and interaction session which will be run every week, that is every Tuesday from 7 to 9 p.m. If you have any questions, you can raise your hand or unmute yourself and then raise a query, or you can also post the questions in the chat box. Apart from this, if you have any other questions, you can always go to the Swayam portal and raise the question from the Ask a Question tab, that is the discussion forum for the course. And any questions related to the live session conducted can be raised and will be addressed in the forum by a course member in the same or the next week's live session or in the same week as well. So for today's live session, we'll go through the week 2 course content recap. That is the lecture number 4, that is surface tension and energy. Lecture number 5, wettability. And lecture number 6, which is adhesion and cohesion. Next, we'll also solve certain questions related to the week 2 course content, and we may try to discuss it as well. I hope that there is no doubt until now. So we may go forward for the session. Okay, fine. So let's now go through a quick revision of the week 2 course content. So we will start from lecture number 4, which is surface tension and energy. So in this, first of all, we went through what is adhesion and what is cohesion. So as you can see from the first figure, in case of adhesion, it is the energy required to separate two different media. Whereas in case of cohesion, it is the energy required to separate two similar media. So here in case of similar media, it has been denoted with 1 and 1, and in case of adhesion, two different medias or molecules have been represented by 1 and 2. Next, we were taught about what is work of adhesion, that is work of adhesion between two interfaces 1 and 2 is equal to surface tension of 1 plus surface tension of 2 minus interfacial tension between the two molecules. So these 1 and 2 may be any solid or any liquid. So if I represent the solid with 1 and the liquid with 2, the formula may change into WSL is equal to gamma S plus gamma L minus gamma SL. Next, we were taught about that in case of any soap experiment, the work is given by force multiplied by area. Here, force is given as the product of surface tension and the length. So, surface tension can be written as force per unit length. Next, we were also okay. So next we went through the Maxwell relations, which gave the relations between the differential surface entropy, the differential surface tension, as well as the differential surface enthalpy. So am I being audible? If there is any problem during the session, you may always write it down in the chat box or even just unmute yourself. Okay, fine. So after the Maxwell relations, we went through the discussion between the surface tension and surface energy. So for solids, the surface energy is greater than the internal energy, as the free energy of the outermost atoms is not nullified, as they are not equally attracted in all the directions. So surface energy increase by increasing the surface area. Also, adsorption of foreign molecules on the surface of solids causes reduction in surface energy. So this surface energy in case of liquids is called as surface tension, which is the attraction force exists between the surface molecules of liquid. Also, surface molecules of the liquid get farther apart with the loss of molecules, causing the increase in the net attraction between the molecules and hence high surface energy. Liquids tend to reduce the surface energy by minimizing the surface area. So next in the lecture, we discussed about the Dupre equation, which basically gives the idea or the relations between the work of adhesion and the interfacial tension. That is, gamma 1 2 is equal to gamma 1 plus gamma 2 minus W12. So as I said earlier, for solid liquid interface, if you denote, if you the if solid is represented by 1 and liquid is represented by 2, the formula will change into gamma SL is equal to gamma S plus gamma L minus WSL. Next, we also discussed about the work of adhesion in a third medium. So what happens if any two molecules or two objects are placed in a third medium such as water? The work of adhesion can be represented by W132 is equal to W12 plus W33 minus W13 minus W23. Next, this work of adhesion can also be written as 2 in the bracket gamma 1 gamma 2 power half. So now this gamma 1 can have two components, that is, one is the dispersive component and another is the polar component. So if we substitute the gamma 1 and gamma 2 along with their dispersive and polar components, so we'll get the equation as W12 is equal to 2 gamma 1d gamma 2d power half plus 2 gamma 1p gamma 2p power half. So here is a table of some of the compounds and their surface tensions in terms of dispersive as well as the polar components. So next we'll move on to the lecture 5, that is wettability. In this lecture, so we were made understand about what is the term wettability, which is the ability of a fluid to spread or adhere to solid surface in presence of other immiscible fluids. So wettability when is basically represented by the contact angle. That's the contact angle when it's 0, it's called complete wettability. When it is less than 90, it is partial wettability, and when it is greater than 90°, it is non-wetting in nature. Next, we also studied the Young's equation, which gave the relation between the contact angle as well as the interfacial tension. That is cos theta is equal to gamma SV minus gamma SL divided by gamma LV. Also in Young-Dupré equation, it gave the relation between work of adhesion and the interfacial tension as well as the contact angle, which is WSL is equal to gamma LV bracket 1 plus cos theta. Next, we also went through what is spreading coefficient, which is given by WSL minus WLL is equal to gamma SV minus gamma LV minus gamma SL. In the same lecture, we also studied about in the same lecture, we also studied about the effect of chemical heterogeneity on wetting, which was represented by the Casey equation, wherein cos theta was given as F1 cos theta 1 plus F2 cos theta 2. Also, we studied about the effect of physical heterogeneity on wetting, given by the Wenzel equation, wherein cos theta is equal to Rf cos theta naught. Rf is the roughness factor, which can be calculated by actual area divided by the projected area. So this surface roughness, that is the Wenzel equation, is cos theta rough is equal to roughness factor cos theta, which is the true contact angle. Now for Rf, when it is greater than 1, the macroscopic contact angle theta is lower than the theta naught. And when the Rf is less than 1, the macroscopic contact angle theta is higher than theta naught. So when theta naught is less than 90 degree, the theta decreases with increase in roughness, and when theta naught is greater than 90 degree, the theta increases with increase in roughness. In the same lecture, we also went through the contact angle hysteresis, which said that the advancing angle is greater than the receding angle. It mainly focuses on the surface heterogeneity, the change in the chemical and physical nature of the surfaces after they have come into contact with a liquid or another material, as well as the adsorption of surfactant to a surface from an advancing liquid. So lastly, in lecture 6, that is adhesion and cohesion, the spreading of one liquid over another was being described about, that is SB by A is given as gamma A minus gamma B minus gamma AB. And we also studied about the Giri-Falco and good geometric mean rule. So this, just wait a minute. Okay, I'll ask Uzma, can you please mute yourself? Okay, fine. So, okay, let's move on. So we were discussing about the Giri-Falco and good geometric mean rule, which is given by W12 is equal to 2 phi gamma 1 gamma 2 power half. So this phi is a function of the molar volumes of 1 and 2, and it should be in unity if molecular diameters obey a geometric mean law. Similarly, I think we discussed this equation earlier, only the thing is here the phi is added. Next, we also discussed about the interaction between two bodies. So in this case, this table has been taken from the book itself, which you can I think see it in page number 255 of the book, and wherein the energy as well as the force components between two atoms or small molecules have been given, as well as two flat surfaces, two spheres or macromolecules of radii r1 and r2, and lastly sphere or macromolecules of radius r near a flat surface has been described about. So the energy between any two flat surface, as we can see, is given as W flat is equal to minus A by 12 pi d square. Similarly, force is given as minus A by 6 pi d cube. Next, the JKR theory of adhesion mechanics was being described, wherein two spheres of radii r1 and r2, elastic moduli k, and surface energy W12 per unit area will flatten when pressed together under an external load or force, that is F, such that at mechanical equilibrium their contact area will have a radius which is given by A cube is equal to R by K under root 3 by 2 pi RW plus minus under root F plus 3 by 2 pi RW to the whole square. So for the sphere on flat surface of same materials, R2 is taken as infinity and R1 is taken as R and W is taken as 2 gamma SV. So on substituting it, we get A naught as 6 pi R square W by K to the power 1 by 3. And lastly, if the sphere is pulled by a constant force F, it will detach from the surface when F reaches the adhesion force. Now the force of adhesion is given as minus 3 by 2 pi Rw, which is equal to minus 3 pi R gamma SV. Next, the adhesion hysteresis was discussed, as well as the adhesion of rough and textured surface were also discussed. So for polymeric materials to show adhesion hysteresis due to chain interdigiting across the contact area as a function of time. So the metals and inorganic solids show hysteresis due to slow coalescence or chemical sintering reactions. Now these reactions add up to adhesion energy, which is also called as loading energy, which is the advancing work of adhesion, and which is less than the unloading, that is the receding work of adhesion, giving rise to hysteresis effect. Lastly, the adhesion of rough and texture surfaces, similar to that of the contact angle, we can see that force of adhesion is equal to force of adhesion, which is 0 e power minus sigma by sigma naught. Sigma naught is the constant and FAD 0 is the JKR adhesion force for smooth surfaces, and the repulsive part becomes exponential. So I hope all the three lectures you might have gone through the same as well from the Swayam portals. So now we will move on to some of the question and answer discussion, which will help you to solve the week 2 assignments and also your final examinations. So let's now move on to the first question. So let's begin. The question is, which of the following is or are true for work of adhesion? Your options are: A. It is the energy required to separate two different media. B. It is the energy required to separate two identical media. C. It is an irreversible work done. And D. All of the above. So which of the following is true for work of adhesion? So any guesses? Okay, you might think of what is work of adhesion first and then try to solve this question. You may also think about the difference between adhesion and cohesion to rule out any of the option which is not suitable here. You can post your answers in the chat box as well if you are feeling shy to give the answer by unmuting yourself. So we will solve the assignments quite slowly, and so that you also can go through the questions very well and think about the same. Okay, so which one of the following is or are true for the work of adhesion? Energy required to separate two different media, energy required to separate two identical media? Work of adhesion is an irreversible work done, or all of the above? Okay, let's now discuss the answer for it. So, work of adhesion is the energy required to separate two different media. Now, why not the other options are correct? We'll move on to that. So, energy required to separate two identical media is termed as cohesion and not adhesion. Similarly, work of adhesion as well as cohesion both are reversible work done and not irreversible work done. So, I guess this question is quite clear to you. So, work of adhesion is the energy required to separate two different media, whereas energy required to separate two identical media is termed as cohesion. And in case of work of adhesion, it is a reversible work done and not an irreversible work done. So, fine, we'll move on to the next question. So, the next question here is the SI unit of surface tension is your options: A, N, that is Newton per meter, B, Joule per meter square, C, Joule per meter, and last, both A and B. So, anyone would like to try to give this answer? This is probably quite an easier one. You may post your answers in the chat box. So the SI unit of surface tension is Newton per meter, Joule per meter square, Joule per meter, and last option is both A and B. I'll give you 1 minute. If you can just try to remember or recall anything about this SI unit of surface tension, or if you had solved any questions earlier. Okay, fine. I have not received any response, so I will move forward. So the SI unit of surface tension is both A and B, which is Newton per meter as well as Joule per meter square. Now, why both of these are correct? So, in units of energy, we can write it as Newton per meter, and in case of force, that is in units of force, the SI unit of surface tension can be written as Joule per meter square. So if you convert Newton into Joule per meter, you will easily get it as Joule per meter square. I hope there is no confusion, or if you guys have any doubt, you may raise your hand for any query. Okay, so now I think you guys are clear enough for what is the SI unit of surface tension, which can be either Joule per meter square or Newton per meter. So we will move on to the third question. The third question for today's assignment is, higher the surface energy. Option A, you have to complete this sentence or complete the statement. The higher the surface energy, option A is lower the cohesion strength of molecules. Option B, lower the adhesion strength of molecules. Option C, higher the adhesion strength of molecules. And option D is higher the cohesion strength of molecules. So higher the surface energy, which of the option is the correct one? You have to complete the statement. So anybody would like to give it a try? You may even try for the wrong answer, like it's not necessary you might always be right, but it's better to go for, it's better to try rather than just to sit back. So just think about the concepts of surface energy and try to correlate it with adhesion and cohesion. First, try to relate where we use the term surface energy. And I'm not talking about surface tension, rather, I'm talking about surface energy. And then think about what was the difference between cohesion and adhesion. Okay, okay, fine. We may just move on with the answer as I'm not able to get any response. So, higher the surface energy, the higher will be the adhesion strength of molecules. First of all, when I talk about surface energy, I said we use the term surface energy when we are dealing with solids and not liquids. So in case of cohesion, we are separating two similar media, whereas in case of adhesion, we are focusing on separating two different media. So we will already rule out the option A and option D when we are relating surface energy and adhesion, and we are not relating surface energy with cohesion. Next, why when the surface energy is high, the adhesion strength of molecule will also be higher? Because it follows that if a particular surface has a high surface energy, it will wet more easily. And since the ability to wet a surface is in turn a simple definition of the adhesion characteristics of the surface. It will be easier to glue, print, paint or bond to that surface. So basically we are trying to relate wettability, adhesion and surface energy. So fine, higher the surface energy, higher will be the adhesion strength of the molecules. I hope I'm sorry guys, I think I lost my connection. Can you give me a clarity about from where you all left? Otherwise, I will repeat this question once more. Just so we were basically talking about this third question, which is higher the surface energy, what will happen to the adhesion strength of the molecules? So higher the surface energy, higher will be the adhesion strength of the molecules. Why so? First of all, surface energy, we relate it with solids and not liquids, as in case of liquids, we use the term surface tension. Also, when you think about the difference between adhesion and cohesion, adhesion was the energy to separate two different media, whereas cohesion is the energy required to separate two similar media. So when I'm using adhesion and we don't have to relate the surface energy with cohesion. So we are going to rule out option A and option D. And next, why the higher the adhesion strength of the molecules, the higher the surface energy? Because it follows that if a particular surface has a higher surface energy, it will wet more easily. And since the ability to wet a surface is in turn a simple definition of the adhesion characteristic of the surface, it will be easier to glue, print, paint or bond to that surface. So I hope this question is clear to you. Was the PowerPoint presentation visible till now, or is there any problem? I hope the PPTs and my voice is also clear and the PowerPoint presentation is also visible to you. So if at any point you may find difficulty or if you are not able to listen to my voice or unable to look at the presentation, please mention it in the chat box or you can also raise your hand so that the query can be resolved. Okay, fine. We'll now move on with the next question, which is question number 4. So which one of the following have the highest surface energy? Just now we dealt with a question relating to the surface energy, and here also we have been asked which one of the following have the highest surface energy. The options are A. Wax, B. Teflon, C. Metal and D. Water. So anyone would like to answer to the question? Try to answer. So which one of the following have the highest surface energy? Your options are wax, Teflon, metal or water. Just now we did a question where we knew that the higher the surface energy, the higher will be the adhesion strength of the molecules. So try to correlate the statement to this question. Okay, so the answer to the question is metals. So why metals? We'll see. So metals usually have high surface energy and thus they easily get wet by suitable adhesive. Just now we went through the statement which said that higher the surface energy, the higher will be the adhesion strength of the molecules. So metals have high surface energy and thus have high adhesion strength. Next, waxes are not easily wetted because they have low surface energy. So low surface energy, and you all know that wax cannot get easily wet. Next is Teflon. Teflon, as you all know, are used in the non-stick cooking utensils. These have low surface energy and hence have less adhesive properties. Similarly, water has low surface energy and thus you cannot, if when you compare metal and water, metals have higher surface energy. So fine, I think the options and the reasons were quite clear so that we can move forward with the next question. Okay, let's move on to the next question. So, question number 5, Dupre equation gives the relation between A. Interfacial tension and work of adhesion, B. Surface tension and interfacial tension, C. Work of adhesion, interfacial tension and contact angle, and D. Work of adhesion and contact angle. Just now, in the starting of the session, we revised about various equations which also involved Dupre equation, Young's Dupre equation. So if you can just try to recall what was the Dupre equation, you may be able to answer this question. So any guesses you want to make? Feel free, as there is nothing you all are not going to get any marks from my side. It's just a discussion session and you can try to give the answer to the question. Don't worry whether it is right or wrong. You may post it in the chat box. I'll repeat the question once more, that Dupre equation gives the relation between options are A. Interfacial tension and work of adhesion, B. Surface tension and interfacial tension, option C is work of adhesion, interfacial tension and contact angle, and option D is work of adhesion and contact angle. Okay, fine. We'll move on to the answer and we'll see what's the correct answer to this question. So as you all know, work of adhesion is represented by W12 you can say, and interfacial tension is gamma 12 and contact angle is theta. So the correct answer to the question is option number A, that is interfacial tension and work of adhesion. We will see why. So as you can see, Dupre equation is gamma 12 is equal to gamma 1 plus gamma 2 minus W12. So here you can see that it gives the relation between the interfacial tension and work of adhesion. In case of Young's equation, we see it is given as cos theta is equal to gamma SV minus gamma SL divided by gamma LV. So Young's equation gives the relation between contact angle and the interfacial tension. Whereas in case of Young-Dupre equation, it is given as WSL is equal to gamma LV 1 plus cos theta. So in this case, it gives the relation between work of adhesion, interfacial tension and contact angle. Work of adhesion is WSL, interfacial tension is gamma LV and contact angle is theta. So as you can see from the options, we have been asked about Dupre equation. So the equation as it states is it gives the relation between interfacial tension, that is gamma 12 or gamma 1 and gamma 2, and the work of adhesion, that is W12. I hope this question is clear to you, and if not, you may ask me to again repeat it. I can repeat it for you. You need to remember the equations, then only you can solve the further questions as well. Okay. Fine, we will move on to the next question, which is question number 6. So question number 6 is non-wetting liquids have a contact angle theta of option A less than 90 degrees, B greater than 90 degree, C 45 degree and D 0 degree. So non-wetting liquids. Anyone would like to answer this question? We have been asked about the contact angle in case of non-wetting liquids. So think about a surface, and when you pour a non-wetting liquid over it or a wetting liquid over it, what can be the contact angle between the interface of this liquid and the surface? So non-wetting liquids have a contact angle theta of less than 90 degree, greater than 90 degree, 45 degree or last 0 degree. Okay, so the correct answer to the question is greater than 90 degree. So why? We'll see when we talk about wettability. Anything which have the angle less than 90 degree is partially wettable, which is greater than 90 degrees is termed as non-wetting, and when the contact angle is around 0 degree, it is called complete wettable in nature. So when you see a surface and you pour a non-wetting liquid over it, which is hydrophobic in nature. Remember that non-wetting liquids are hydrophobic in nature. So the contact angle between that surface and the liquid will always be greater than 90 degrees. In case of wetting liquids, which is, as you can say, hydrophilic in nature, will always make a contact angle that is less than 90 degree. And those liquids which have high wettability property, the contact angle between the surface and the liquid will be 0 degrees. For I guess there is no doubt till now. So I am not receiving anything from yet in the message box. Fine. So we can now move on to the next question, the seventh question. So the next question is, according to contact angle hysteresis, which of the following statement is true? What does the contact angle hysteresis basically states? So the options are A. The advancing contact angle theta A is smaller than the receding contact angle theta R. B. The advancing contact angle theta A is equal to the receding contact angle theta R. Option C. The advancing contact angle theta A is larger than the receding contact angle theta R. And last option is none of the above. So think about contact angle hysteresis and try to answer the question. So in the recap section of today's session, I think I discussed contact angle hysteresis as well. And Uzma, Techno, Akhileshwar or Smriti, anyone would like to answer, you can just post it in the chat box if you're not feeling free to unmute yourself and give the answer. So there was a picture related to contact angle hysteresis when I was going through the recap of week 2 course content. So try to recall that picture and give the answer. Fine, we'll try to give and see. Let's what the answer to the question is. So according to contact angle hysteresis, the advancing contact angle theta A is larger than the receding contact angle theta R. So as you can see from this figure, what happens is any liquid when it is advancing towards a surface, which is termed as the contacting advancing angle, and any liquid which is receding back, and the angle formed between the surface and the liquid is termed as the receding angle. So according to contact angle hysteresis, the advancing angle, that is theta A, is larger than the receding contact angle, that is theta R. Hope it is quite clear from the image. I hope there is no doubt yet, because from next question onwards we'll try to solve certain numerical questions. I divided the assignment, half of the assignment is basically theoretical, and rest of the half of the assignment is focusing on certain numerical questions. So let's move on and try to solve some of the numericals. Okay. So last theoretical question is wettability of a surface with chemical heterogeneity is given by option A, Cassie equation, option B, Wenzel equation, option C, Dupré equation, and D, Young's equation. I will repeat again, that is wettability of a surface with chemical heterogeneity is given by Cassie equation, Wenzel equation, Dupré equation, and Young's equation. So most of these equations were also revised in the recap session. Try to recall in which lecture did you where you taught about the effect of chemical heterogeneity. Effect of chemical heterogeneity on wettability is represented by which of the equations? So first try to rule out the options which you are totally sure that they won't be in the answer to the question. For example, option C and option D, as we just discussed in last to last question, what was Dupré equation and what was Young's equation about, and what kind of relation it was talking. So you have option A and B left with you. So think about what was Cassie equation and what was Wenzel equation. Okay, fine. We'll see what's the answer to the question. So the answer to the question is option A, Cassie equation. So why Cassie equation? Because Cassie equation is represented by cos theta f1 cos theta 1 plus f2 cos theta 2. Whereas Wenzel equation is given as cos theta is equal to Rf cos theta naught. Now as you can see, in case of Cassie equation, we have this factor F1 and F2, whereas in case of Wenzel equation, it has RF, that is the roughness factor. So Wenzel equation does not talk about the chemical heterogeneity, whereas it talks about the effect of physical heterogeneity on the wettability of a surface. And Cassie equation, F1 is the fraction of the surface which has various chemical regimes, and hence Cassie equation gives the wettability of a surface with chemical heterogeneity. As in case of Dupre equation, it does not talk about the wettability, rather than it gives the relation between the work of adhesion and the interfacial tension. In case of Young's equation, it gives the relation between the contact angle and the interfacial tension. Hence, Cassie equation gives the equation for wettability of a surface with chemical heterogeneity. Fine. I hope everything is clear till now so that we can move forward. Okay, let's move on to the numericals now. So for the first question, we have for N-hexane bromonaphthalene system, calculate the interfacial tension between these two, that is the gamma 1,2 in terms of millinewton per meter. Your options are A 16.42, B 5.64, C 18.4, and last D 4.44. So we have to calculate the gamma 1,2 in terms of millinewton per meter in case of a N-hexane and bromonaphthalene system. We have went through the lecture 4, 5 and 6. I think one of the similar questions were also discussed during the lecture period. Probably it was between N-hexane and water system. So if anyone had solved such question, you can try for solving this question as well. Okay, we'll wait for 30 seconds or you want more time to solve the question. If not, if you don't have any idea, I'll always, I'm also going to discuss the answer to the question. We'll see how to solve this question. So the answer to the question comes as 5.64 millinewton per meter. So we'll look out what are the equations which are required to solve this question. Here we have W12 is equal to 2 gamma 1 dispersive, gamma 2 dispersive to the power half plus 2 gamma 1 polar, gamma 2 polar to the power half. So to solve this question, you need to have the value of gamma 1 both in the dispersive and the polar component, and the surface tension 2, that is that of bromonaphthalene system, both in the dispersive and the polar component. So this table right here, as you can see, has the value of both N-hexane and bromonaphthalene in terms of their surface tension in dispersive as well as the polar component. So now anyone would like to solve this question and tell me the answer to it? The answer is already there, that is 5.64. I only want your verification at least. If anyone could try solving the question. Okay, fine. We may solve the question. So the question here is, for N-hexane bromonaphthalene system, you have to calculate the gamma 12 in terms of millinewton per meter. So as you can see, the gamma 1 in case of dispersive hexane is 18.40, whereas the polar component is 0. In case of bromonaphthalene, it is 44.40. The gamma D and gamma polar is 0. So I will write the question here. So you can try to solve with me. So here we have W12 is equal to 2 gamma 1 dispersive gamma 2 dispersive to the power half plus what we have is plus 2 gamma 1 polar gamma 2 polar to the power half. So from the table we have this polar component as well as this polar component for N-hexane and bromonaphthalene as 0. So this component will cancel out. And if you try to solve this component, we have gamma 1 dispersive and gamma 2 dispersive value, that is gamma 1 is hexane and gamma 2 is bromonaphthalene, as 18.40 millinewton per meter, and gamma 2 dispersive is 44.40 millinewton per meter. So if you solve this, if you put these values in the equation, you will get something as 44.40 to the power 1 by 2. Can anyone now solve this for me? If you have calculator or you can use your mobiles. What would be the answer to this question? Just solve this. You can post it in the chat box. So our question was, we have to calculate the gamma 12. So we don't have this W12 component, that's why first we are trying to solve this W12, and then when this value comes, we'll put on into this equation, as we already know the gamma 1 and the gamma 2 from this table. So this table you may find it in the book and various other tables also, where you can see the surface tension of some of the compounds. Okay, let's move forward then. So the value for this W12 will come as around 57.16. Fine. Now when we have the value of W12 already, we can simply put this value in the formula of gamma 12 is equal to gamma 1 plus gamma 2 minus W12. So this gamma 1 and gamma 2 we can relate back from the table. For N-hexane it is 18.40 and for bromonaphthalene it is again 44.40. So simply we have to put the values for determining the gamma 12, which is 18.40 plus 44.40 minus W12, which came as 57.16. So I think now it is quite clear and you all can just give me the answer to this. Calculate this. We can verify the answer whether it is 5.64 or not. You can post it in the chat box. Uzma, Techno, Akhileshwar, Smriti. Any one of you. I just solved it in the calculator also. So the answer is coming to be 5.64 millinewton per meter. So this is what we are looking for. The question demanded gamma 12 in terms of millinewton per meter. So for an hexane bromonaphthalene system, we have when you calculate gamma 12 and you don't have W12, so first try to solve the W12 and then put the value of it in the Dupree equation, which is gamma 12 is equal to gamma 1 plus gamma 2 minus W12. So it was a straightforward question. However, you didn't have this chart with you, so probably you could not able to solve this question. Let's move on to the next question. I hope everything is clear until now. Then only we will move on to the next question. Everything is clear? Uh, Anyone? Okay. Let's move on to the 10th question, which is calculate the surface tension of water at 20 degrees centigrade in millijoule per meter square. Now the differential surface enthalpy is given as 117.3 millijoule per meter square and differential surface entropy is given as 0.152 millijoule per meter square. The options here are A 117.3, B 0.152, C 44.54 and option D is 72.8. So you have to calculate the surface tension of water at 20 degrees centigrade in terms of millijoule per meter square. Now think about where did you relate this surface tension with surface enthalpy and surface entropy. So while I was going through the recap also I mentioned certain equations which talked about the differential surface enthalpy and the differential surface entropy. Anyone who is trying to solve this question? Okay, we'll see how to solve this question as well. So the answer to this question is 72.8. Now, how come we have gotten this answer? So we are using Maxwell relations, as I already told you. Maxwell relation giving the relationship between the differential surface entropy and the differential surface tension, as well as the surface enthalpy. It is the differential surface enthalpy delta H by delta A. Differential surface entropy is delta S by delta A at constant T, P and N. And this is differential surface tension, that is delta gamma by delta T at constant A, P and N. So here in this question, you already have been given the surface enthalpy and surface entropy values. So you just need to put these values in the equation to get your gamma, that is the surface tension of water at 20 degrees centigrade. So now you already know the equation. So you can try to solve this. Okay. So what do we have here? We already have the so we need to find the gamma surface tension at 20 degree of water. We don't know this term, right? So from the table or from the already given values, we have the surface entropy as well as the surface enthalpy, which we can write as dH by dA. We have it as 117.3 millijoule per meter square, and also we have the entropy, that is ds by dA at constant Tpn, which is given as minus 0.152 millijoule per meter square, and the temperature we have is 20 degrees centigrade. So we may convert the temperature in terms of Kelvin, which can be written as 293 Kelvin. Now you just need to put these values to get the gamma. So dH upon dA at constant Tp and N plus T ds upon dA, sorry, it would be, okay, it's ds upon dA, Tp and N. You just need to put on the values. Gamma would come as 117.3, that is millijoule per meter square, plus 293 Kelvin and minus 0.153 millijoule per meter square. So let me just, so this minus 0.152 has also have the unit K with it, right? So K will cancel also. So now the gamma will come as around 117.3 plus minus 44.536. So this can, if you calculate it, you will get around 72.764 millijoule per meter square. So this was the answer we were looking for, that is gamma. Okay. So I hope 72.8 is the answer. It is around 72.764, which can be written as 72.8, and probably This is the final answer, and I hope everything is quite clear. So when we are writing plus, it will be actually gamma and not S. So we may just correct this thing. It will be gamma. So now del gamma by del A is actually equal to minus del S by del A. So minus del S by del A has the value of minus 0.153, which is true here. I think till now everything is clear. Fine. We may move on to the next question. So the 11th question is, you have to calculate the work of adhesion of water on a solid where the contact angle is 106 degrees and the surface tension of air-water interface is 72 millinewton per meter. So the work of adhesion of water you have to calculate in the terms of joule per meter square. The contact angle is given as well as the surface tension of air-water interface is given as 72 millinewton per meter. Your options are A 52.2, B 72, C 52.2 into 10 power minus 3 joule per meter square, and last option is 72 multiplied by 10 power minus 3 joule per meter square. So anyone have any idea how to calculate the work of adhesion in terms of the surface tension of air-water interface and contact angle? I think we went through certain equations which may directly give you the value or the answer to the question. If you are trying to solve this question, I would wait because it's also a straightforward question. You just need to put on the values. So this is basically you have to use a simple equation which is the Young's Dupré equation, and then you may be able to get the answer. So we'll see what's the answer to the question is. It is 52.2 multiplied by 10 power minus 3 joule per meter square. So you have to use this Young-Dupré equation here, that is WSL is equal to gamma LV 1 plus cos theta. So theta has been given you, like it has been given straightforwardly in the question, that is contact angle is 106 degrees. Gamma LV is also given, that is the surface tension of air and water interface. Liquid is water and V is, that is vapor, is air, which is 72 millinewton per meter. You just need to calculate the work of adhesion of water on a solid, that is given by WSL. Solid and liquid here is water. But the thing is, the surface tension is given in terms of millinewton per meter, and you have to determine the answer relating to joule per meter square. So you have to take care of the units specially, and rest everything is just you have to put the values and solve the equation. Okay, fine. I'll solve for you. Basically solve with you. So gamma LV was already given how much? That is 72 millinewton per meter. What else was given? The contact angle, which is theta, that is 106 degrees. And you have to find the work of adhesion, which is around, we don't know, in joule per meter square. So just using the Young's-Dupre equation, what was the equation? WSL is equal to gamma LV 1 plus cos theta. So we have WSL, we have gamma LV, we have gamma LV and we have the cos theta. We just need to determine the WSL. So, so what will be the WSL if I put the values here? 72, 1 plus cos 106. So what is the value for cos 106? Will come at around minus 0.275. Fine, now you just need to calculate this and you will get the answer probably as 72 multiplied by 0.729. So you will get the answer as 52.1254, around something similar to this. So the unit here is millinewton per meter, but we need to convert this into joule per meter square. So first we'll convert this is also equal to millijoule per meter square, and you can just write this as 52.2 multiplied by 10 power minus 3 joule per meter square. So you got your answer as WSL, or work of adhesion. Here we have is 52.2 multiplied by 10 power minus 3, which was the option number C. So I hope this question was also clear to you, how to calculate the work of adhesion of water or any liquid on a solid surface which has certain contact angle, and when you already know the surface tension of the interface. Now we will move on to the next question. Next question is question number 12. Water contact angle at a smooth surface is 60 degree, which decreased to 55 degree with an increase in surface roughness. We have to estimate the roughness factor. So your options are A, 0.2, B, 0.647, C, 1.647, and D, 1.147. So let me give you the answer as the option. So the answer is 1.147, and you have to solve this question using the Benzel equation, which is cos theta is equal to RF cos theta naught. Is the question clear to you? Cos theta is equal to RF cos theta naught. You have to just apply the true contact angle value and you may get the roughness factor. The initial and the true contact angle value you have to put. You have to just remember that the water contact angle at the smooth surface is 60 degree, which decreased to 55 degree with an increase in surface roughness. So remember here that already in the question there is a hint that the roughness has been increased. So the RF value will already be greater than 1. So option A and B has already been ruled out, and option C and D, you already have it. The answer is 1.147. Can you try to just calculate this question? Okay. So we'll see how to calculate this one. So we have the contact angle of 60 degree, which was the initial contact angle and which we termed it as theta naught, that is a true contact angle. Now the surface got rough and the contact angle decreased to 55 degree. So we already have the theta naught and the theta, and we just have to take out what is RF, and we have to use the Wenzel equation. What is the Wenzel equation? Cos theta is equal to RF cos theta naught. Just when you put cos theta, that is cos 55 degrees, is equal to RF, and cos theta naught is how much? 60 degree. So RF would come as cos 55 degree divided by cos 60. So what will be the value of cos 55 and cos 60? You may also check in your calculators. If anything is wrong, you may just point out to me. So cos 55 value is approximately 5735, and cos 60 value is approximately 0.5. You have to just now divide this and give me the answer. The answer is quite now in front of your face, that is 1.147. Roughness factor is 1.147. So since CRF is greater than 1, therefore the surface is a rough one. I hope till now everything is clear. It's just basic maths. You have to just know which equation to put in where. You must remember the equations to solve each and every problem. I think the numerical sessions are I really want to take your feedback as well if these numerical sessions are clear and easily understandable to you, because I've selected questions related to the week 2 content, and it will probably help you in solving both the assignment questions which are uploaded now and the final examination questions. So okay, we in the last question, so we can see we solve this question using the Wenzel equation. Fine, so let's move on then if there is no doubt. So the next question is, determine the contact angle between a mica and surfactant solution interface with the surface tension of 11 millinewton per meter, wherein you have been given the surface tension of solid as 27 millinewton per meter and the surface tension of liquid is given as 40 millinewton per meter. The solid is mica and liquid is the surfactant solution. The options you have is A 66.4 degree, B 54.4 degree, C 45.2 degree, and D it's 54 degree. So you have to determine the contact angle between a mica and a surfactant solution interface which has the surface tension of 11 millinewton per meter. So you already have all the three values, that is the gamma 1, gamma 2 as well as the gamma 1, 2. You just have to determine what's the contact angle. The answer to the question is 66.4, and you have to just use the Young's equation, which is cos theta is equal to gamma SV minus gamma SL by gamma LV. So gamma SV is your gamma solid, that is solid vapor. So it will be 27. Gamma SL is your gamma 12, which is the surface tension of 11 millinewton per meter between the mica surfactant interface. And your gamma LV is the gamma of liquid. That is the surface tension of liquid, which is 40 millinewton per meter. You have to just put on the values and solve the equation. So anyone would like to verify the answer? Is it coming as 66.4? Sorry people, I think there was a certain lagging in the network. Are you all able to listen to my voice? Okay. So you have to just use the Young's equation and solve the question. You already have gamma SV, gamma SL and gamma LV. Fine, we'll try to solve this question as well. So from the question, you can see you have been given the values already, which is gamma 1 is equal to gamma SV is equal to 27 millinewton per meter. Then you have gamma 2, which is termed as gamma LV, which is given as 40 millinewton per meter. And lastly, you have also been given the gamma 1 2, which is gamma SL is equal to 11 millinewton per meter. You just have to put this value in the Young's equation, that is cos theta is equal to gamma gamma 1 minus gamma 1 2 by gamma 2. So how much would it come as? 27 minus 11 divided by 40. So you have around 16 divided by 40. So when you divide this, you get the value as, so let me see, 16 divided by 40 is equal to around 0.4. So cos theta is equal to 0.4. How much will be the theta? That you can find out by putting cos inverse 0.4. So you just need your calculator with your hands, so that you can just put on what's the value for theta, that is cos inverse 0.4 will come at approximately 66.42 degrees. So this was the thing which we were, sorry, let me just erase this. So we were looking out for the contact angle between the mica and the surfactant solution. So fine, I think this is also clear. You all can verify with me, or you can also calculate simultaneously with me, so that it will be easier for you also to recall. Okay, so we did the 13th question, that is determine the contact angle between a mica surfactant interface with the surface tension of 11 millinewton per meter. In this case, you were given the gamma 1 2 as well as the gamma 1 and gamma 2. You just need to put the values in the Young's equation, wherein you can simply find out the contact angle. Okay. So let's move on to the next question, question number 14. So the question 14 is, you have to estimate the adhesive energy for two planar surface in contact, which has the value of diameter of 0.25 centimeter, and the options here given as 21.22 millinewton per meter. Second is 4.24 millinewton per meter. C is 21.22 joule per meter square, and lastly 4.24 joule per meter square. So you have to estimate the adhesive energy. Adhesive energy is, don't confuse yourself with work of adhesion and the adhesive energy. Here adhesive energy is given in terms of the interfacial energy. Fine. So the answer to the question is 21.22 millinewton per meter. And how would we solve this question? We will use this certain equation, that is in case of two flat surfaces. See, in the question it's given, you have given two planar surfaces in contact. So this table was already given in page number 255 of the book, Intermolecular Forces, by Jacob Israelishvili, and the gamma can be calculated as WAD by 2, or work of W11 by 2. So we'll try to solve this question as well, but I will be very happy if you will also solve this question with me. We have to, in this question, there are two equations involved. So we will try to separate the PPT and try to solve this question, that it will be easier for you. So you have been asked to find out the adhesive energy. So in this case, in case of polar, how do we determine the work of adhesion? It's been given by minus A by 12 pi d square. Now the value of d you already know. Now A here is Hamaker constant. So A is given as 10 to the power minus 19 joule. This you may very easily find in the book if you once go through it. And D you have been given as 0.25 centimeter. So we'll convert this 0.25 in terms of meter. Sorry, the question is wrong here. It should be nanometer. It's not centimeter, it's nanometer. Okay, we'll solve the question now. So you already know what is the value of A, that is 10 power minus 19. So here we have the minus sign as well, and then we have 12 and 3.14, and we have t square, that is 0.25 into 10 power minus 9 to the power 2. Now you just need to calculate this forward. So 10 power minus 19, and this would approximately come as, how much will it come as? It will come something close to 2 point this into 10 power minus 18. Can anyone confirm me that is it right or not? Yes, it's correct. So we'll get around this value, and so the work of addition, we finally got it as around 0.424 10 power minus 1. So we can write it as 4 point. So here is the minus sign. Don't forget the minus sign. 4.24 multiplied by 10 power minus 2. Now this is joule per meter square. Since Hamakar constant was given in joule and D was in meter. So we got the WAD as minus 4.24 10 power minus 2 joule per meter square. Now you just simply need to put this value in to find your adhesive energy. So how much will it come? Divided by 2. Will come at something around 0.021. Right. Let me just check it once in my calculator. So the question demanded you the answer in millinewton per meter. So we'll convert this joule per meter square in terms of millinewton per meter, and we'll get the answer to approximately. So 1 joule is how much? Millijoule. It's around 10 power 3 millijoule, right? So if I convert then in terms of millijoule, it will be something around 21.22 millijoule per meter square. And then if I convert this in 21.22 millinewton per meter. So here you have your answer. So this was your option number A, that is 21.22 millinewton per meter. I hope everything is clear for this question and you have quite the understandability. So okay, we have one more question left. We'll just go through it and we'll try to wrap up this session. Fine. Have you all noted down the answers? If not, this whole session or even the PPTs are uploaded in the Swayam portal. You can go through it like assignment 1, week 2, week 3, week 4, and after that you will find a tab which is called the problem solving sessions. From there you can go and get access to all the PPTs as well as the video links. Okay, so let's move on to the last question of today's session. So we have the question as the spreading coefficient SB of A and SA of B of two immiscible liquids A and B at a temperature of 25 degrees centigrade were reported to be 45 millinewton per meter and minus 54 millinewton per meter respectively. So the surface tension of A is given as 72.8 millinewton per meter, and you have to determine the surface tension of B as well as the interfacial tension of between A and B in terms of millinewton in units of millinewton per meter. So in this question, the spreading coefficient SB by A and SA by B both are given, that is 44 millinewton per meter and minus 54 millinewton per meter respectively. The surface tension of A is also given. You have to find out two factors, that is gamma B, that is surface tension of B, and surface tension of AB. So your options are A 12 and 23.8. That is surface tension of B is given as 12 and surface tension of, that is interfacial tension AB is given as 23.8. B is 23 and 12, C 23.8 and 5, and D is 5 and 23.8. So the correct answer to the question is 5 and 23.8. So you have to solve this question using two equations. And what are those equations? Sorry. What are those equations? Are SB by A spreading coefficient is equal to gamma A minus gamma B minus gamma AB. Then we have SA by B as gamma B minus gamma A minus gamma AB. So how are you all going to solve this question? I have already given the hint. You all can just try at least for this particular question. The spreading coefficient of SB by A and SA by A, both the values are given, and as well as the temperature is given, the surface tension of A is given. You just have to find the surface tension of B and the interfacial tension between the interface of A and B, but in terms of millinewton per meter. So here in this question you don't have to convert any units because all the units are given in millinewton per meter. So let's try to solve this question. So let me see what are the values given. First we'll write the values. What are the values given? So SA by B is given as 44 millinewton per meter, and SB by A is given as minus 54 millinewton per meter. Also what you have to find, you also have your surface tension of A, which is 72.8 millinewton per meter. You guys have to find the surface tension of B and the interfacial tension AB. So let's try to put in the values in the equation. Let's see. So SB by A as of here is given by gamma A minus gamma B plus minus, this would be minus. So minus gamma A minus gamma B minus gamma AB. I hope my PPT is visible and I have a good net and audible as well. Okay, so this equation can again be written in terms of, if we club it, we can write it as gamma A minus gamma B plus gamma AB. Right. So when we put on the values, we get this as 44 is equal to 72.8 minus gamma B plus gamma AB. Right. So one of the terms we need to take in common. So here I am trying to take in common as gamma B, which again I can write it as minus 44 plus 72.8 minus gamma AB. I hope until now everything is clear. And again when I try to put the value of SA by B, I will get it as gamma B minus gamma A minus gamma AB, and this I can write as gamma B minus gamma A and plus gamma AB. So when I put the values here, what do I get? I get as minus 54 is equal to gamma B minus 72.8 plus gamma AB. So again I can take gamma B as the common one and I can rewrite the equation as minus 54 plus 72.8 plus gamma AB. Quite right, is it or not? Is everything right here? Did I get any message or something? Okay, we'll move on. Okay, fine. Now we may club these as, this can be taken as the equation number 1 and equation number 2, and we can just try to solve these two equations. How are we going to solve this question? You can just add it or multiply it as per your convenience. So I'm trying to multiply it basically. How we do that? So first equation was around minus 44 plus 72.8 minus gamma AB, and the other equation was around minus 54 plus 72.8 plus gamma AB. So what happened if I subtract it? So we'll get this as minus, this as also minus, and this as also plus. What will happen? This will come, this will cancel out, and we will get around 10 is equal to my 10 is equal to plus 2 gamma AB. Now we can write as 2 gamma AB is equal to 10. Therefore, what will be the value of gamma AB? It will come as 10 by 2, which is 5. So we already got the answer to gamma AB, which is around 5 millinewton per meter. Now you can just put the value of this gamma AB to any of the equation and just solve it for gamma B, right? So we'll solve it. We got the gamma AB as 5 millinewton per meter. Now if I go to the first equation wherein we talked about the spreading coefficient of B by A, so it can be written as this one, and if I fill the value, so we already know this, we already know this, and then we don't know this, but now we know gamma AB. So how much can we get for gamma B is equal to 72.8 minus 44 . So 72.8 minus 44 minus 5. How much do we get as gamma B now? It will come at around 23.8 millinewton per meter. So we were able to solve both the gamma AB and gamma B values. So are we all clear till now? The last question was a bit lengthy, but when you solve it in paper, it doesn't take much. When you solve it in paper, it doesn't take much of your space. In case of presentation, it looks quite lengthy. And so we have completed this session with solving the 15th question, which were the spreading coefficient of uh, we solve using the spreading coefficient equations, and we determine the interfacial tension as well as the surface tension of B, which came as 5 and 23.8. So I hope this numericals were easier to understand, and thank you all for joining in this session. I think a lot of numericals were being solved in this session unlike the previous ones. So I would urge you again, if you have any doubt regarding the weekly contents which are being uploaded in the SWAYAM portal, you can just go in the uh, portal, as well as there is a tab called Ask a Question, and you can just go through the discussion forum and comment or post your questions there. So this was a nice session, and I hope we'll meet again in the next Tuesday with week 3 contents. So let's now wrap up the session, and you all can leave now. Okay, Leshwar has said thank you, thank you. Good night, everyone. We'll meet in the next session, which is next Tuesday, 7 to 9 p.m. Thank you, Uzma. Thank you, Akileshwar. And just now Smriti left. Fine.